Hi, everyone.
Hi, Rob.
Hey. So I wanted to just kick off this afternoon session and express my appreciation to the organizers of this event. I think I feel a lot of pride today that I'm at an institution that can have this type of convening of minds. I think it's a real testament to the vision and the priorities of the deans and the university that this type of event can happen. There's no doubt in my mind that this is an incredibly hot area of research. And I think it's really good that we're thinking about ways to collaborate and push this area forward. So I'm specifically talking today about a project that represents a collaboration between the College of Education, Informatics, NCSA. We're doing some prototyping in their creative studio labs, as well as students in computer science, informatics, engineering. And this is a project that's being funded by the Cyber Learning program within the NSF. And so the Cyber Learning program is looking to develop transformative technologies that are built and developed in alignment with our emerging understanding of how people learn. And so this is a really exciting opportunity to be doing this project here and to be aligning it with the goals of this center and this lab. So the specific goals of this project are first to understand the embodied nature of STEM learning. How do our movements, gestures, and basic physicality support reasoning in areas such as science and engineering? And second, we seek to design new simulation and game technologies that are responsive in real time to these movements and gestures, giving students the opportunity to express their nascent ideas and to be given feedback about those ideas in a give and take sort of way. So the theoretical basis for this work comes from an emerging area of scholarship around embodied learning, which is based on the premise that how people think and how people learn are rooted in the composition and the actions of our bodies. So how we move and interact with the physical world is going to create insights that are going to allow people to develop new understandings. So when it comes to designing, effective educational environments, it's not simply a matter of, getting kids moving, hey kid, do 20 sit-ups and then take a quiz. It's really about thinking, carefully about how their movements connect and support the concepts that we want them to understand. So it's about building a congruency between activity and with thinking. So fortunately, we now have a number of new technologies and new capacities for capturing more of the natural and expressive ways that we interact with the world. So there's devices like the Connect and the Leap Motion that are increasing the possibilities for how we can engage students with digital learning resources and expanding the kinds and the quantity of data that we can collect about the process of learning. So lots of new opportunities for data mining and big data analysis. So what is it that we want people to learn? So in this project, we're interested in whether gesture or other movements can support higher order or more abstract reasoning in STEM. So specifically, we are targeting the cross-cutting concepts that have been outlined by the next generation science standards. So these are things like notions of scale, causation, patterns, and rates of change. These are ideas that are central to a number of different areas in science and engineering, but for a student to successfully transfer those ideas across areas and to know that they should transfer is a historically difficult thing to do. So our hope is that we can empower students to transfer these big ideas by giving them common schemas for communicating that's grounded in their own physicality. So on the technical side of things, we realize that we're going to need some pretty sophisticated machine learning techniques to be able to take the data that you get from these motion capture systems and make intelligent inferences about what the child understands and what it is that they are trying to communicate. The ultimate goal of the project is that we build these simulation theaters that are going to allow students to interact and engage these simulations in a range of STEM topics using this common gestural grammar. So what are the things that this project can lend to a learning sciences design lab? So the first thing is that it can bring, we hope, foundational research on how body movements and gesture support the higher level reasoning in STEM. We can also bring algorithms and software that capture the nuances of learning related gestures. So this can be useful for our project, but also hopefully for other projects that you guys are working on. And opportunities for data analysis. So I hear a lot of people talking about different types of data that they can be used to be analyzed. Movement data is one of those types that can present challenges and also great opportunities for linking that to educational outcomes. And finally, we hope to be a model for collaborative research and design across the social and the applied sciences, and to really show that these things can be synergistic and powerful.